E aí, gurizada, boa tarde, tudo bem? Espero que estejam bem. E aí, Fabrício?
E
Álvaro?
aí, Sebastião? Eu acho que
Fabrício,
a gente fez um
hoje...
pouquinho só de confusão, né? No videoclipe.
Cara,
Eu tá.
quem não entendeu, viu 3 vezes. Fabrício, eu acho que esse é o último, né? Acho que é o último PGConf localhost que a gente vai ter esse ano, não é mesmo?
Exatamente. É a última palestra, como todo mundo sabe, esse ano por conta da pandemia, a gente teve que cancelar o evento presencial, né? E para não deixar esse ano passar batido, não ter nenhum conteúdo a respeito da PGConf.Brasil, a gente resolveu fazer essa série de palestras que iniciou em junho. E aí tivemos no mês de julho e agora finalizando agora em agosto com o nosso grande amigo Álvaro Hernández, que já é de longa data nosso parceiro e já apresentou vários conteúdos. Inclusive a primeira PGConf, quando a gente rebatizou o evento em 2017, o Álvaro estava lá e apresentou uma bela de uma palestra para a gente era sobre o ToroDB.
Sim,
It's about ToroDB, Álvaro.
it
Yeah,
was.
yeah. Então, galera, Sebastião, tem mais coisas para te falar aí.
Eu acho que tem que lembrar a galera de se inscrever no canal, de deixar o like e de contar para todo mundo que tem uma palestra muito legal aqui. Também, para quem não tem uma ideia, eu acho que o Álvaro meio que fala por si só, porque é um cara popular na comunidade Postgres, ele contribui com muita coisa. Quem acompanha ele no Twitter vê que ele anda ultimamente muito preocupado com o MongoDB, ele anda fazendo bastante coisa, bastante comparativo sobre isso. E ele hoje, ele é a única pessoa que eu conheço que coloca a analogia de eu sou um empreendedor serial, então eu foco muito no projeto, foco muito no outro projeto, segue, que é uma coisa muito legal. E hoje ele é o CEO da Ongres e ele vai falar para nós hoje sobre Postgres e Kubernetes, que é o que todo mundo quer saber, né? Como é que eu vou usar o Kubernetes? Porque o Kubernetes vai dominar o mundo, resolver todos os problemas, e a gente vai rodar Kubernetes até na geladeira, se der tudo certo.
Isso aí, importante também. Perguntas, galera, no chat. Quem quiser fazer ela direto em inglês, a palestra vai ser em inglês, agora a gente vai fazer o switch para o inglês para conversar com o Álvaro. E quem quiser fazer a palestra quem quiser fazer a pergunta em português, também pode fazer, a gente traduz sem problema nenhum. Mas o Álvaro entende bastante coisa de português também.
Não
Ele é
vai xingar o cara,
envergonhado,
hein?
mas
Não vai
ele
xingar o cara,
entende.
hein?
A little bit, but you understand a lot of things. I know, I
Yeah,
know.
pretty much some parts of it, yes.
Okay, so let's go then, Álvaro. I think the stage is yours, and thanks a lot, man, to accept our invitation. You always be more than welcome here with us. We hope next year you can come to Brazil in person, because that was the plan.
Yes.
No, and thanks a lot. The stage is yours, and okay, we will remove ourselves and let's go to the show, man.
Yeah, and
Okay.
if anyone has a question, we'll stop you and explain the question, then we'll reply and you get out again. So have a nice presentation. We are here. Bye.
Yeah, bye.
Thank you both, and thank you for the introduction. I think I pretty much understood everything you were saying, Sebas, and that was funny. All right, so hello everybody. Sorry I cannot falar português. I can understand more than speak, but I hope you're good with my non-native English anyway. So first things first, as Fabrizio and Sebas said, feel free to ask any question anytime. They'll interrupt me. I prefer to be interrupted. I don't want you to wait until the end and then throw a bunch of questions. That may happen too, of course, but let's do it more interactive. Throw them anytime you may have any question. And don't bother asking questions if you think they're too basic or too stupid. As I usually say, the only stupid question is the one that you don't ask. Because maybe it wasn't stupid, maybe everybody can learn from it, maybe I can learn from it. And so let's make it as interactive as you can. Thank you, everybody, all the organization behind PGConf.Brasil for inviting me. yes, I would have wished I would be now physically in Brazil, but at least I'm hopeful that next year I may be. And to now at least now I feel virtually at least in Brazil, where I am virtually in Brazil. So let's get it started. As I said, interrupt anytime, shout a question anytime. By the way, I think this will be shared in the comments. There is a poll on Twitter where you may vote for options. I would like to know how familiar you are with Kubernetes. And based on that, of course, I'll make more or less introduction about some parts of the talk. By the way, this talk is meant to be also mostly a demo. So I have a lot of slides actually, but I'll go more or less quick over them. I don't want to overwhelm you with the slides. I want to make a demo. The demo is quite complex, involves many commands, many steps, and it may fail at any time. That'll make it probably even more interesting if it does. But let's try, of course, not to. And if it works well, you'll see, I would say, very impressive features of running Postgres on Kubernetes, which might give you some ideas about how to deploy Postgres in the future. So with all that said, let's get this real started. First, the obviously presentation about myself, even though I've been already introduced. So I don't want to make this also very long, but basically, I founded a company called Ongres. Ongres means on Postgres, and that obviously means that we are a Postgres-only company. We focus a lot on R&D, on research and development. We try to come up with new ideas to complement the Postgres ecosystem and to build solutions that doesn't exist or that could exist in a novel and better way, like the one we're going to cover today about Postgres on Kubernetes. I usually speak at many conferences and talks. Each one is very important for me. I keep track of all of them. I have my personal website. You can look it on the internet by my name. Anyway, the URL is aht.es. So there's all my slides, videos, recordings, and references to all the conferences that I have given. This year, I planned to reach to 100 talks in the last decade. Because of COVID, many conferences were canceled, and I will not make it probably. But if not, I'll make it next year. So yes, I speak a lot at conferences. And I also want to contribute back to the Postgres community. I founded the Postgres community in Spain and a non-profit association also in Spain, a foundation for Postgres. The user group in Spain is among the 10 largest Postgres user groups in Spain. And I also recently became an Amazon hero, a recognition from Amazon due to Amazon database expertise. So first of all, let's start with the demo. So actually, this demo, I want to start really from scratch. I want to demonstrate that there's nothing prepared at all. So the first thing, because we're going to talk about Postgres on Kubernetes, right? So the first thing that we need is Kubernetes. And I don't have any. So the first thing I want to do is create one. Because this process takes around 20-25 minutes. I'm going to run it right now, the commands to create a Kubernetes. And then we'll switch back to the slides. And if everything goes well, we'll have a Kubernetes afterwards. All the code that I'm going to be running, it's public. It's on this URL. It's on gitlab.com/ongresinc, and then StackGres tutorial. So if you want to check it out, if you want to follow, run the commands in parallel, if you have an Amazon account, because I'm going to run all the examples on Amazon Cloud, you can also do it. Otherwise, obviously, you can do it later on. So let's go. I hope you can see the screen. You can see all this while shout on me. And font size is okay. If there's anything you cannot see, please let me know. So this is a clone of this GitLab repo, Git repo that I just showed on the screen. And if you look here, there's a directory setup environment. We're going to set up an environment on Amazon using the AWS command line interface. And the first thing I'm going to do is just create an Amazon managed Kubernetes cluster. So we do that with the command AKSCTL and passing a few parameters or defining some variables. This is not super really important or part of my presentation. If you want to go and dive deeper into this, you have the source code available. But basically, this command is going to create a Kubernetes cluster spread through 3 availability zones on Amazon in Europe right now because of the variables, version 1.17 with 3 nodes. That's pretty much everything we need to know at this point. And since this is going to take some, as I said, some time to run, let's just start running this and go back to the presentation. Obviously, as I said, if there's any questions so far, let me know. So before starting the presentation, let me do a quick parenthesis here and talk about a problem that is not specific to Kubernetes, as specific to Postgres. And it's what I call the stack problem. So let's look at container sizes, because that's easy to do, and compare the size of an installed base of Oracle and installed base of Postgres. As you probably can see in the slides, if you look at Postgres, the default image weighs around 350 megabytes. But there is even a reduced image based on Alpine Linux that weighs under 100 megabytes. That's pretty tiny, I would say, for a database. Now, if we even look at the Postgres source code, it is no more than 20 megabytes. Of course, it's not compiled, but and there's no data directory, and there's a few caveats there. Well, there's no data directory either on the images that I mentioned, but it's tiny from this perspective. Now, let's look at Oracle. If you take an Oracle 12 version, and I haven't run this with the more modern versions, that would be funny to do, probably it's even bigger. It weighs 3.5 gigabytes. So we're talking at least a 10 times bigger size. And where is this coming from? Is that Oracle is so much better than Postgres that includes 10 times more features, and that's why the container image weighs 10 times more? Well, the answer is obviously no. This we probably all know at this point in time. But the difference is the tools. Postgres is kind of a little bit bare bones. It is an awesome database. It is a great database with a lot of features, absolutely comparable to those of Oracle. Some things better, some things less, but the database at the core is very good. However, if you look at the tools that come with Postgres, well, basically Postgres doesn't come with a few tools that are, PSQL and PGBench and a few other tools that come with Postgres. But in general, most of the tools that a DBA would expect to use in a production environment, they don't come with Postgres. In Oracle, they come with Oracle. Obviously, this is also part Oracle comes from a single vendor, but this is the difference. So what is this? Is this a good thing or a bad thing? Well, to define this more precisely, what I say is that Postgres is like the kernel of Linux. So you know what the kernel is, right? It's a fantastic piece of software that boots your hardware and talks to the device drivers, brings the device drivers and talk to the devices and expose an API to consume it. But then to run Linux, you need the GNU part. You need the tools, you need the shell, you need the grep, you need the init, you need whatever, right? And this is a distribution. So if we would make this an analogy, we can say that Postgres is like the Linux kernel. So to run an enterprise workload, we need tools around it. We need this distribution. So we basically need a distribution of Postgres, a stack of components on top of Postgres that will bring us to a production enterprise-ready environment, right? So where do we find these tools? Where do we complement this Postgres kernel, this Postgres core, and find the tools that make up this stack? Well, as I said, on the ecosystem. So the ecosystem is this all components, free software, open source software, even commercial software too, of course, contributed by different vendors, companies, individuals that complement Postgres and bring all these tools together. But as I said, this is a good or a bad thing, and it's actually both. It's like Dr. Jekyll and Mr. Hyde. So on the good side, we have a lot of variety. We have many options to choose from. We have variety. There's nothing brought by a single vendor that if you don't like it, you're pretty much done, right? So it brings a lot of different architectures, different opinions, different way of implementing a given functionality. But the bad part is that there's a lot of variety. Surprisingly, the same argument. And this is so because you need to be an expert to actually find what is good and what is bad for the ecosystem. And some tools are not good, or some tools don't work on this scenario, and you really need to understand that they will not work well under these circumstances. They will work well under different ones. So this is a problem, and we have seen in our experience doing professional services that most users are actually confused by the ecosystem. They really don't know what to pick, which tools are good, which tools are not that good, how to configure, how to make them work all together, because each one has its own configuration file format, its own technique for configuration. Some are more prepared for automatic deployments, some are not prepared for automatic deployments, and this actually ends up becoming a problem. So what are these tools that I'm referring to that I believe you need to have an enterprise-grade Postgres or a Postgres stack, this set of components layered on top of Postgres that brings you all the functionality? And I think this is all summarized in this kind of puzzle wheel here. And let me describe each and one of these items in a little bit more detail for you to understand what I'm trying to explain here. So first of all, configuration. Postgres is a database with very conservative defaults. If you just say apt-get install Postgres, you won't deploy that into production because the Postgres, this default config file is tuned like work well on a Raspberry Pi or your Android phone, but not necessarily on a 96-core, 400 gigabytes of RAM with fast disks Postgres server, right? So you need to tune the config. And how easy is this? Oh, it's actually pretty complicated. Postgres has around 300 configuration parameters that you may tune. So, which one to tune, how to tune it, which values to put there, it's a hard task for many, unless you're like a Postgres expert. Most people have a challenge and have a hard time with this. There's actually a project that it's pointed out here. It's called PostgreSQL call.nf. It's like the Postgres config file, like PostgreSQL.conf, but shifting the dot to the right by 2 positions. PostgreSQL call.nf, which is a website that we have created. It's totally free to use, that brings together all the documentation and recommendations about each parameter that you may find in Postgres configuration. And it's also translated to several languages. So you might find it quite useful. And there's also another presentation that I have given at several conferences, and it's become quite famous. It's called Postgres Configuration for Humans. You may also search for it in a search engine, and it contains more specific recommendations about tuning parameters. So anyway, for deploying Postgres enterprise workload, we need some configuration, some initial tuning. And there's only this kind of tools recommendations in the ecosystem. But then we also need connection pooling. And I'll not get into much detail with this, but trust me, you pretty much always need connection pooling with Postgres. It doesn't come with connection pooling included. And if you don't, you'll experience saturation issues, higher latencies, and basically you might want to use a connection pool to control the amount of connections that goes into Postgres to keep it operating at the optimal regime. So, okay, which connection pooler to use? Well, actually, there's 3. There's actually even 4 today. We can talk about PG Bouncer. We can talk about PG Pool. It also does connection pooling. Odyssey. There's now PG Growl also. So again, which one to pick? And by the way, where do I install the connection pooler? Do I front the database with it? Do I put the connection pooler at the client side? Do I put the connection pooler as a middleware? Some of those combinations, all of them. These are all valid questions, and this is difficulty for users, but this is a key component of the stack. Same with high availability. There's PG Pool, obviously manual high availability. Nobody wants to do that anymore. But then there's PG Pool, there's Rep Manager, there's Patroni, PG Auto Failover, there's PAF, there's Tolon. Which one to pick? And high availability is a critical component. And in my opinion, not all these tools are good. So you don't want to risk to have a split brain in your cluster, right? Or to have no master because of a failure of the HA system. So you need to pick the right tool. And again, there's so many to pick. Same with backups. I guess you already got the point. There's Varman, there's PG Backrest, Wall E, Wall G, kind of a successor to Wall E. There's PG Pro Backup. And where do I store the backups? Do I store them on local disk? Do I send them to the cloud? Many questions to answer. Logs. Well, there's not much actually in the industry here, but just imagine you have a 12-node cluster, master and 11 replicas, and something happens, and you need to trace back something that was executing on one node, and then there's logs on the other one, because the application was maybe doing a read-write query that was going to the master, then it was doing a read-only query that was going to another replica. It slowed down, so probably the next query was going to another replica. And in order to trace what happened, you need to go and SSH into each and one of these nodes involved, and then grab the logs or parse them and filter and do AWK, awk, or whatever. And it's hard, especially if you need to repeat these operations across many nodes. So why don't we centralize the logs? Why don't we have like a distributed log server where we can send all the logs automatically from all the nodes of the cluster to a central location where I can query them? Right? This is something that you will see that's already been done for this solution for StackGres that we're going to talk about today. Then we can talk about proxying Postgres. Even though we have a connection pooler, that's typically not enough. And we may want, for many reasons, to introduce an intermediate proxy to front-end all connections to Postgres. Modern proxies like Envoy, for example, are pretty good at this task, and they can be controlled remotely. They have programmatic APIs. They can export metric to about the traffic that goes through them. And actually, let me please, because it's a special day today, today has been announced a new blog post that I co-authored with Fabrizio about an extension, a plugin, if you want to call it that way, that we developed in combination with all the people, with all the teams for Envoy precisely to support the Postgres protocol. So now, if you use the Envoy proxy, you can set it up with Postgres compatibility, and then it will capture metrics about the traffic that goes through the Envoy proxy, export them to Prometheus monitoring system, and provide you very insightful information about Postgres without touching Postgres. You don't need to configure anything in Postgres. You don't need to restart Postgres, install any extension in Postgres. It's totally transparent. You basically capture this at the proxy level. If you want to check the link, this has been published on cncf.io blog page. Here it is. Sorry, not this one. My apologies, this one. So just go to cncf.io and you'll find this blog post. I recommend reading it. It's interesting, I would say. All right, so this is another piece of the stack that we may want to have, but obviously we also need monitoring. And the story repeats again. There's so many monitoring tools. I'm not going to even read them. You can read on those slides which one to pick, how to configure, how to bundle them all together. Last but not least, most users want a web UI, or not web, but like a UI or a console to administer the clusters, the systems, and all these parts of the ecosystem from a single pane, right, where I can look at all of them. And there's actually not so many developed here, but as we will see, StackGres also counts with one. So there's too many pieces of this stack. It's not a simple saying, oh, I want to deploy Postgres into production, apt-get install Postgres, done, right? 30 seconds. Oh, well, we can do that, but we'll not be happy with the result. We're going to need to go and bundle all these parts together and create what we call this stack, the Postgres stack. All right, so this is what describes the stack, all the components that I need. But where do I deploy this stack? Because there's so many different environments, right? There's cloud vendors, there's Amazon, there's Google, there's Azure, there's on-prem environments. And how do I deploy all this? It's going to be quite tough, right? Because all these environments are different. They have different APIs for deployment. I love IAC, infrastructure as code, basically creating a code that will create the infrastructure. That could be Terraform, CloudFormation, Ansible, etc. But each environment is different, and just look at all these components that I mentioned. It's going to be a really hard job to write this automation, this code to deploy this on each of these environments, and on-prem is like infinite number of environments, right? And this is, of course, if I do IAC, like infrastructure as code, if I do it manually, this is going to take weeks to deploy a Postgres cluster, including all these components. Just imagine all the config files for each and one of these components, make them everything work together, test it, and then a different environment comes with different networks, with different capabilities, and everything's going to be different. So this is a really tough problem. How do we pack this in a single way? How do we find a way to deploy this into a single environment that will work regardless of where that environment is? And that's the key to Kubernetes. So let's switch to the next section of the presentation, which is how to deploy a Postgres stack on Kubernetes. I'm going to make a really quick pause. Any questions so far here?
No questions so far.
All right.
They are so behaved today.
Okay, I hope we'll break that trend though.
Okay.
All right. So I'm not gonna get into a lot of details here. But basically, first question: why do we want Kubernetes? Kubernetes, if you start looking for definitions, if you're not super familiar. Oh, by the way, let me ask you: what's the results of the poll? Do you have it handy?
Let me check the results of the poll. Just a moment. I didn't reply. I will say, what is KATS? 44% say that's somewhat familiar, and 32% say it's quite familiar. We have 25 votes so far.
Okay. So even more reason not to go into a lot of details, but if any of you who are not totally familiar, you think you're missing some point, make a question, okay? But basically, very briefly, Kubernetes is an abstraction layer over a distributed architecture. And this is the key to solve this problem that I was referring to, how to package all these components together and deploy them. And instead of creating dozens of versions of this package, this stack of components, do it only once. And the key is Kubernetes.
We have the first question. I think it's super useful. Guys, is the Kubernetes the concurrent of Docker?
Okay. So Docker is a containerized environment. It runs packaged workloads into a container image and allows you to run them. Kubernetes is kind of a layer on top of it. It's not exactly the same thing, but think of a layer on top of it. And Kubernetes is typically defined as an orchestrator. And what does an orchestrator mean? Well, an orchestrator mainly means that it's able to schedule these workloads and say that you have a uniform pool of nodes. And this is Kubernetes terminology already. Servers become nodes. They form a pool. You don't care which server is which. And you just say, oh, I want to deploy 3 copies of this container in my cluster. And Kubernetes will find where, if there's enough capacity, which nodes these things will run, these containers will be deployed. These containers can be run with Docker, can also run with other Kubernetes container runtimes. But Kubernetes is the system that will find where to deploy these workloads, how to wire them together, if one depends on the other, to create a DNS entry for some of them you're exposing as a service, to restart one if it fails, to expose things externally, to provide you with storage options, to connect to some volumes like disks that are, for example, if you're in a cloud environment, to create a volume for you and to attach it to your container. If the container fails and is restarted on a different node, to reattach this volume to the correct node, to the correct container, so everything magically happens. So that's kind of Kubernetes from the perspective of the orchestration, which is kind of the more official definition. My definition, obviously that's absolutely 100% true, but focus more on the API side. So Kubernetes by itself, it's an API. It's actually an HTTP server. It's a REST API. That's Kubernetes. And this REST API, what it does is exposes objects, and these objects have behavior. So when you create an entry via HTTP and you say, I want to create a pod, and a pod is a set of 1 or more containers packaged together also, it will schedule and create those resources for you. So it's very good because it's hiding behind an API, the behavior to deploy infrastructure. And the cool thing about it is that it's abstracting away the real infrastructure behind the scenes. It has like drivers for networks, drivers for volumes. They might be dependent on the environment, but only that part, only the drivers, but the API is independent of them. So by programming against this API, you can deploy volumes, pods, networks, DNS entries, load balancers, and many other components in a standardized way. That's why I call it the JVM of the distributed systems. Probably not all of you love the JVM as I do, but the analogy may be quite handy, because the JVM, it's a uniform API. It doesn't matter where you're programming against a Mac system or a Linux system or Windows system or Solaris or whatever. Just use the Java APIs, and that code will run everywhere where there's a JVM. So this is pretty much similar. If you want to deploy something on a given distributed infrastructure, as long as you code it against the Kubernetes API, it will just be the role of the system administrator, which installs and manages this Kubernetes cluster, that will make it work with that environment. But you, as an application developer, let's call it that way, you'll just use the API. You can test it on any system. It doesn't need to be the final system, and everything should and actually does work very well. For the demo today, I'm creating a cluster on Amazon, and Amazon offers this as a managed service. So I just need to say, I want to create a cluster with 3 nodes, and Amazon will take care of this administrative part. I will not take care. I could do it by my own, obviously, just spinning up some VMs on EC2 and then installing a Kubernetes distribution on top of it and fixing these driver parts. But it's so much more convenient to do it like this. And Amazon will manage this part. So for me, that's a Kubernetes API standard. And now I'll be deploying workloads on top of it.
Alvaro, let me stop you. Bruno asked if this approach, I think he's talking about the idea of the Postgres stack, will work on Swarm too, the Docker Swarm.
Okay, that's another fair question. So Docker Swarm is also kind of a scheduler, the orchestration layer, same as Kubernetes. But I would say that Docker Swarm, as of today, is, I mean, it's not that it's deprecated, but it's in a much less popular point in time, and it's also much less developed. It has significantly fewer capabilities compared to Kubernetes. Conceptually, yes, they do the same role, but I would say that Kubernetes is much more spread, much more advanced, much more developed, and I don't think that Docker Swarm will get very far, actually.
Okay, go on.
Sounds good. Okay. As I said, if there's questions or concerns, please share them. All right, so one key of Kubernetes is what is called the operators. And the operators is, an operator is just a Kubernetes application, but it's a special one. It's an application that understands a domain problem, for example, deploying Postgres on Kubernetes, and it will take care of doing all the hard work, talking with this Kubernetes API when you say, hey, deploy me a Postgres cluster. But there's 2 keys to an operator. One is the software that runs and will take these actions. It's called a controller. And then there's another part, which I'm going to talk today a lot about it, which is called a CRD, or a custom resource definition. A custom resource definition is, as I said before, Kubernetes exposes objects, and you interact with these objects. But it also allows you to create custom objects. And so an operator defines its own custom objects and allows you to interact with those objects. What is the advantage of this? These objects can be very high level, and at the same time can hide all the complexity behind the scenes. So you'll see right now with code that one of these high level objects, one of these high level CRDs, can be a Postgres cluster, right? And there, for the user, for you as a user of Kubernetes, instead of needing to specify which high availability system you're going to use, which configuration file, which directory the Unix domain sockets are going to be running, which specific parameter is going to be on this config file, how the monitoring is happening, which is the path to the PG data to the logs, and all the low-level details, those are all hidden and programmed into this operator. And the CRD, if it's well-designed, will expose you a very, very simple, lean interface, like, okay, how many nodes do you want? Do you want replication, yes or no? Do you want connection pooling, yes or no? And that's it. So a well-designed operator, it is something that will take all the expertise of the domain-driven experts, in this case, Postgres experts, and programming it into code and expose to you as a user a very simple interface. This is something that I will try to show today. At least I should be able to do that. Okay, I have a few other slides here, but let's just go directly to how we take a Postgres and make it into a cloud-native application in Kubernetes. Basically, there are some questions sometimes. Is Postgres for containers? The answer is yes. There's many reasons. We can enter into a long debate about this, but basically there's no performance overhead. Containers are not virtualization layers. I mean, they are, but not like in the OS virtualization. They're very lightweight virtualization, and there's basically no performance degradation if you use external volumes, which is the only way to go, and it's obviously the only thing that we're using here. So it should not be a concern. Actually, it could be much better because Kubernetes and cloud-native environments bring you the possibility that if something fails, it will be restarted elsewhere, then this volume will be reattached, and everything will actually reheal much easier than on a non-Kubernetes environment. So it could be actually even better. Well, another interesting part here, I'm going to skip this a little bit more, but basically containers should be minimal. They should not contain what is not necessary. It's not contain documentation, extraneous binaries, just the bare minimum files required to run a process. And this leads to a question that we'll also see in during the demo, which is, let's leverage a sidecar pattern. And the sidecar pattern is basically, in Kubernetes, the unit of deployment is called a pod. And within a pod, you can deploy more than one container. And those containers, you may separate the functionality. And so, for example, in our case, we have one container which is called Patroni, which contains Postgres and Patroni. But then PD Bouncer is a separate container. And then Envoy Proxy that I mentioned before is also a separate container. And then the metrics export to Prometheus is a separate container. These are all are called sidecars. Instead of bundling everything together and building a gigantic container, which is very hard to maintain, to evolve, where this is, what if you need to separately security patch one part of it, but not the rest, and makes it very hard to reuse. You can, with this sidecar pattern, split functionality into orthogonal components and then bundle them together into a Kubernetes pod. So we exploit this a lot. You'll see that StackGres pods actually contain typically up to 6 containers, the main one and 5 sidecars. Okay, high availability. We're not using Kubernetes high availability mechanism. We use a specific Postgres high availability mechanism. This comes with significant advantages, and we use Patroni for this. And we'll see about this centralized logging pattern that I mentioned before. Okay, so let's go to the real meat. What is StackGres? This is an open source software that we have created. It's open source. It's published on GitLab and also on github.com. By the way, if you like this talk, please go and give us a star. We really appreciate that. And you can obviously contribute, test it freely. Well, you know the deal, right? It's open source. So the key about StackGres is that it's a Postgres stack of components, exactly all the stack that I described before, but brought onto Kubernetes. And the reason why it works in Kubernetes is what I explained before. We can create a single version of a StackGres that will run almost anywhere, meaning anywhere, any place where you can run a Kubernetes cluster. And we don't need to create dozens of versions of StackGres, one for Amazon, one for Azure, one for cloud, and dozens for different on-premise environments. By standardizing in Kubernetes, we can deploy StackGres almost anywhere. And it's designed to be enterprise grade, which means it's ready for you to deploy into production, containing all these components that I mentioned in the stack that actually, I would say, not even many of the systems that we see on a daily basis contain so many of those components, this very complete stack. And at the end of the day, because it's so simple to deploy, I want to show that to you. This is basically like a database as a service. It's like a managed service, except that you have full power. It runs on your infrastructure if you want, or a cloud infrastructure, but you're the owner of it. You have root privileges. You're not limited to a user that has limited privileges. You have everything. You can do whatever you want. It's your infrastructure, but everything is so automated that it's actually completely equivalent to running a database as a service. So, a little bit about the architecture. This is what Postgres pod looks like. I already explained to you the sidecar pattern concept. So there's a Postgres and Patroni main container, and there's several sidecars. There's the Envoy Proxy, there's PD Bouncer, there's one for forwarding the logs, which contains the software from the Cloud Native Foundation called FluentBit. There's the exporter to export metrics to Prometheus, and there's a Postgres util. This is a container where we store the binaries that are for administration that should not be part of the main container, because Postgres just needs the Postgres binaries to run, right? Doesn't need PSQL, for example, or PGBench. They belong to a separate container or utility. If we extend this to the architecture of the system, in the system we may have several pods. One will be the primary, and the rest will be replicas. These primary replicas and election, this is all handled absolutely automatically. There's nothing you need to do. You'll say, I want to create 3 replicas, and the system will create them automatically for you. And then also creates 2 DNS services. A service is just a DNS entry. One always point stably to the master node. So even if the master node fails, another one will be promoted. The DNS will be changed internally. Everything automatically done for you. Your application, as long as it talks to the master or the primary DNS entry, will always get a read-write connection. And then there's a read-only one, which is load balance. So it will load balance across all replicas. Again, if replicas membership change, the DNS entry will internally repoint itself correctly. So you can point to your application to either the primary or the replicas, or both, obviously, DNS entries, and you'll always have stable view of the Postgres cluster, whatever happens behind the scenes. Regarding storage, well, this is not so very important, but we use persistent volumes, which is the only way actually to do serious database stuff. And those have a handle which is called a persistent volume claim, a PVC, the standard Kubernetes stuff. Let's just move forward. And just a little bit for you to understand how these things are wired internally. There's each pod, as I mentioned before, may have connection pooling and envoy proxying for the traffic. This is the default. So all these components will be created by default. They're wired, configured to work together all by default. There's nothing you need to do there. So how does it work? So actually, the envoy proxy exposes 2 ports externally. One is a Postgres port, and the other one is a replication port. And depending on which of these ports, route them internally on a different way. The Postgres or data port is routed through PGBouncer for also having connection pooling, and then from PGBouncer, obviously, to Postgres. Whereas the replication port, because PGBouncer doesn't support replication protocol, and actually there's no point in the connection pooling the replication protocol, it goes directly to Postgres, so as you can see on the diagram. All right, so enough for the slides. Let's go for the demo. Just before the demo, one last thing. Let me go back to this idea of the CRDs. So the CRDs are the customs resource definition, this high-level API that I mentioned before, that StackGres, once it is installed, it will expose. So we will see that these CRDs are kind of YAML files. You can make it JSON, you can create them via HTTP API directly, but the most usual way is through YAML files. I'll also actually show how to do this from the web console, the web UI that also comes with StackGres. They're fully equivalent, but the idea is that these CRDs define a very high-level interface to your Postgres cluster. And
Álvaro, before I continue, Israel is asking if it's possible to deploy StackGres using Helm.
Yes. Actually, we're going to do that right away. So there's a Helm chart for deploying StackGres. There's 2 ways of installing StackGres, a demo mode and a Helm mode. I'm going to demo both. So I think that will answer your question.
That would be awesome. Thank you.
Sure. So back to this last note about these CRDs. These CRDs, again, are the high-level API. You cannot imagine the amount of complexity that goes behind the scenes to make these CRDs super high-level for you. So you don't need to worry about most of the details. Actually, I've talked about today, whether there's Prometheus, whether there's Envoy or not, how Envoy is sending the metrics to Prometheus, how PGBouncer, Envoy, and Postgres are communicating via Unix domain sockets with which paths, how the logs are sent to a central location, so many other aspects, very deep about configuration and tuning, and all those are exposed to very, very high-level natural interfaces, so much that we believe StackGres can be used by non-Postgres experts. As long as you can create YAML files or point and click on a web UI, you should be able to create Postgres clusters with StackGres to a quality equivalent of the very best practices that we, at least we as a company, Ongres, we do for our professional services, multi-billion-dollar companies that we provide support for. So it should be top of the notch quality in terms of advanced and components and tuning and best practices applied, except that you don't even need to know almost anything about Postgres or even Kubernetes. We're going to see this directly. So let's go for the demo. Again, if you want to check the files I'm going to be showing here, this is the URL where you might find all the source code that is published. So I'm going to go back to the console. And okay, good news. Looked like the Postgres, the Kubernetes cluster was created. So just before starting with this, any other question? We're good?
No new questions.
Okay, excellent. All right, so let's give it a try. The cluster has been created. That's good news. Because of the way this tool works, I need to do a small fix to the config file. This should not be part of the demo. Don't worry about this, but I'll fix this very easily. This should do the job. So let's check the cluster. Yep, there's a cluster there, and it works and should be pretty much empty. There's obviously a few items here, but they all belong to the Kubernetes system. So we have created a Kubernetes cluster, and it's empty. It's all for us. We can do everything that we want here. It's got 3 nodes. All looks good. We're running Kubernetes 1.17. So the first thing we're going to do, we have already installed this. Let's go to the simple demo. Let's make a very, very simple demo so you can see how easy this can be in obviously the simplest case. But so installing StackGres could be as simple as running this command. Later on, we'll try to do this with Helm. But for now, let's just run this command. And it should install StackGres in a few seconds. It's just kubectl, I'll type the command here again for you to see, apply-f and a URL. That's the only thing that I need to do on a bare bones new Kubernetes cluster to install StackGres. If all goes well on the StackGres namespace, I should see some pods being created. Yep, it's not finished yet, the post installation actually, but it will be very soon. And I'll have StackGres installed. While this is finishing, let me see how to create a cluster. So once we have installed StackGres, we can already start creating a cluster. And let's see how we would do that. As I said before, StackGres, once it is installed, again, with this very simple command, it exposes these CRDs, these high-level API objects, custom objects. And let's use one of those. So this is an example of one of the objects that is exposed by StackGres, which is called SD cluster, StackGres cluster, which obviously represents a Postgres cluster. By the way, StackGres is vanilla Postgres. There's nothing. There's things on top of it, but behind the scenes is pure Postgres. There's nothing special there. No compatibility issues. No nothing. It's real Postgres, right? Now this is the name of this CRD, of this custom resource definition, and this it's a very simple YAML file. As you can see, this is the name we'll give to the cluster. And all that is exposed here is super high-level interface. So I want 2 instances. I want the Postgres version to be the latest. But I don't even care what it is. It's just give me the latest one that you have, right? And I want this to be 5 gigabytes of disk for Postgres. And that's it. As you can see, this is super high level. Just by running this command, we're going to be creating here Postgres cluster with 2 instances, with envoy proxy, with PG bouncer, with tuned by default Postgres config, with a persistent volume, with Patroni for high availability, with automatically creating new nodes if one fails, and so many other things. Just imagine the amount of complexity that is hidden behind this very, very simple YAML file. So how do I use this YAML file? Well, this is absolutely standard Kubernetes stuff. Just say apply-f and the file, and that's it. And the cluster is in progress. So let's actually check, and the cluster should be creating already. Yep, as you can see here, it's initializing the cluster, and in a few seconds, it takes approximately like around 1 minute, or maybe less than that, depends on downloading the images. I'll have a Postgres cluster with 2 nodes, with high availability, with connection pooling, with envoy proxy, and we'll discuss later about monitoring and all those. Just by typing a 10-line
Álvaro, I have a few questions.
Sure.
We have some requirements to run StackGres. For instance, storage provisioning. Since we're talking about databases and this, we need to persist the state of the data. So we have some requirement for that.
So here, if you see on this YAML file, on the pods part of the specification of this StackGres cluster, you can see that I'm specifying a persistent volume. There's no other way. You need to specify a persistent volume, and you're specifying the size. Now, the key is that this persistent volume, behind the scenes, we are creating also a persistent volume. This is Kubernetes terminology that will go to a part of Kubernetes called the CSI, which is a container storage interface, which will have installed by the Kubernetes administrator a plugin that will talk to the precise environment where you're running this. To be more precise, this is running on AKS, which is the Managed Kubernetes Service by Amazon. Amazon has installed a CSI driver that will talk to its own volumes. So by just specifying this YAML file, behind the scenes, StackGres will talk to this driver and will create a persistent volume. In Amazon lingo, this persistent volume is going to turn into an EBS, an elastic block storage. The volumes by Amazon that are in the network, they are very highly reliable, and they're not attached to a single node. So even if the node fails, the volume will remain there. So all this happens automatically via Kubernetes, the CSI driver that is installed by the vendor, and the work that does StackGres behind the scenes.
Oh, nice. I have a new question from Fernando too. He's asking if the same StackGres cluster support different workloads for the database. I can use the same cluster for two different kind of applications.
I would say the same as Postgres. So Postgres is good for all workloads. Probably not all of them, but most of them, yes. StackGres will work the same way. I don't see any specific difference. I don't think that StackGres is meant for a given type of workload. I think it's equally well for any workload that works with Postgres. Just think of StackGres as really a lot of layers on top of Postgres that help you deploy it automatically, manage automatically, but it's still Postgres behind the scenes.
Got it. We'll have a lot of questions now. They wake up and are typing like hell. Israel is asking. He's telling that his company has a few Kubernetes clusters on premises, and they are using Gluster.fs to provide persistent volume for the applications. But he's telling, I'm not comfortable to using Gluster for database workloads.
Me neither.
Do you have a suggestion for that, or do you think that's super bad idea to try?
Yes, it's not a good one. Yeah. We want. That's why we're specifically relying for now only on a persistent volume. So if you're running this on-prem, you will probably need to get some for your storage. You maybe have a SAN or equivalent hardware, and this will probably have a CSI driver. So just install the CSI driver and then expose this as storage class. On the next example, I'll show how to specifically claim a given storage class for creating the volumes. And then you'll just use the storage class, which will in turn call the CSI driver, which will in turn call the API to your SAN device, and will create a volume automatically. But yes, don't any distributed file system.
Awesome. We have a new question from Marcelo. He's asking, what is the base version of Postgres that you're running on StackGres?
11.
11?
And 12. You can choose.
Okay. I didn't write in the question, but how is how can we apply patches to Postgres if you need to update or something? This is possible to do. I think he's saying como que é a aplicação de pacotes de correção no PG. I think that he's talking about updates, so you can update to a new version.
I think it is about a minor upgrade.
Yeah. Okay. Fair enough. That's a good question. So this is minor version upgrade is actually something specifically coming on the next StackGres version. And the idea is that thanks to the APIs that come with Kubernetes, we're going to be able to fully automate the operation. So it's going to be as simple as actually creating a special CRD that we're going to be providing called database operations. And you're going to say, oh, I want to upgrade from 12.3 to 12.4. That was just published today, right? And it will do a dance around. It will do actually a lot of things behind the scenes. It will talk to the Envoy proxies that are fronting each Postgres instance. It will tell them to start draining the traffic, which means do not allow new traffic, but keep the one that is connected already inside. This will do this first for the replicas, obviously. Once a replica has no traffic, it will replace the container, restart the image, replace the container, bring with a new version, and reattach a new replica to keep always the number, the count the same. And finally, when only the master is in the old minor version, it will perform a failover and so forth. It's a little bit of a complicated step, but everything is going to be fully automated. So for you, it will be creating a 5 lines YAML file.
Oh, awesome. I have a lot of questions. They are not stopping.
This is just the beginning.
Yeah. Avelina is asking, how can I install Postgres extensions using the StackGres, for instance, Postgres?
Okay, that's a very good one. So with current version 0.9, we are bundling several extensions with StackGres. They come with the base image, so you will create them the same way as you create them with Postgres. So basically, go to the database and do a create extension. I'm going to point you where this is available. So if you go to the StackGres.io website, documentation, and here you go to introduction, and there's versions. So in this URL, the versions, you can see all the versions of all the components we're using, and also the extensions. And okay, lucky enough, we have PostGIS already included in the base image, and there's a few other extensions that are already included in the base image. Now, also for the next version of StackGres will be 1.0, we're going to include the ability to install any extension that you want. So that will be a little bit more complicated, but you might need at some point to upload if it's a custom extension. But it's going to be like it's going to contain an extension server and quite a lot of facilities to be able to deploy any extension. This is one of our key principles about StackGres. This is just because of all the automation that comes with StackGres. This is like a database as a service for you, but we don't want to restrict you to this given list of extensions. You should be able to deploy any extension that you like.
Okay, last question, and I think we're ready to go. Marcel is asking for a database that have more than 1 terabyte. There's a loss of performance on the access volume for StackGres or for the Postgres cluster.
I don't see any reason for that. Obviously, it's going to depend. The larger database, the costlier your queries may be, but of course you may use partitioning for those things and all kinds of optimizations. But if we look at the hardware perspective of the problem, which I don't know if exactly that was the point of your question, but if you look at the hardware perspective, it depends on the environment where you are. If this is going to be on Amazon, which is this case, these are using EBS. EBS can grow very large volumes. They support, if I recall correctly, up to 64 terabytes. The performance should be dependent on the hardware that you have behind the scenes. If, for example, you use an IO1 storage class, which is warranted performance from Amazon, you'll get warranted performance from the disk perspective, saving any database optimization you may need to do.
Got it. I don't know if you want to keep going and we'll go back to the questions in a few moments. Or...
Okay, yeah. Let's move a little bit, and we can get some more questions, because actually the next steps may also trigger all the questions. Okay. All right, so you saw that the nodes were correctly created. Now let's demonstrate a little bit that everything is correct. So first of all, we're using Patroni for high availability. This is something that you don't need to worry about, but just because this is a Postgres talk and we are here more or less Postgres experts, maybe you know Patroni and you know this command, patroni_ctl list. If I run this command against one of the pods, I will see that, okay, yeah, I have 2 nodes. These are the IPs. I should not care about these IPs, by the way, but this is the leader. And there's a replication lag. So actually, yes, I see that with this YAML file, there's a Patroni there. And is there a Postgres there? Also, there's a Postgres there. Let's just check it in a very quick and hackish way. But yes, there's Postgres there also. So here I could actually connect to Postgres and do any usual stuff that I want to do with Postgres, right? Like PR, and yeah, everything works. This is really Postgres. And by the way, then I can connect to the replica. Is the replica and list the databases, and yes, it's replicating. So this is a Postgres cluster of 2 nodes, replicating, and everything works, by default. As I said before, if I, for example, let's do this. This was not planned, but let's delete the master node, for example, because I want to. And what is going to happen now? I'm killing the master. A new pod is going to be created automatically by Kubernetes. You see that it's already being created right now, and the cluster is going to be healed in a few seconds. There might be a new election for the new master node, and either the simple one or the simple 2 will become the master. It could be even the old one because of timeouts and re-elections and all these things. But yeah, you can see that the cluster has been healed already, and I can probably repeat the commands that I did before, the patron list, for example. And yep, okay, so the leader changed, and here I have the new leader that was selected automatically. And if I connect to the database and run the commands that I did like before, I'm having everything that I had before. Sorry about that noise. I don't know what it was, but it was weird. So this is this orchestrating capability that Kubernetes brings to the table. Okay, now last but not least, by running this YAML file. So first of all, by installing the StackGres, which was as hard as this, and then creating a cluster, which was as simple YAML as this. StackGres also comes with a web console, and this allows you to do from a graphical interface everything. The very same things we're going to be doing from the YAML files, the very same things you can do also from the web console. And whatever you do with the YAML will appear on the web console. Whatever you touch on the web console will be reflected on the YAMLs too. So they're both equivalent. You want to go command line, you're an expert command line, you like YAML files, go. You prefer the web UI, go. You want to mix and match, also. So let's actually show that. Let me show you this web UI. To show the web UI, the first thing we need to do is just to check how this is going to be exposed. For this demo, we automatically expose a load balancer, and behind the scenes, this will create a load balancer in Amazon, and we'll expose with a public DNS, which is going to be this. So let me just copy this and go to the browser. So if I open the browser, let me know if you don't see this by any reason, but you should. And yes, this is self-signed certificate. But other than that, this is the graphical interface. And here, let me make this bigger, by the way. Yeah, the default username is admin. The password is auto-generated. So let me grab the password. So here there's this, well, not so simple command, but at least there's a command to grab the password. It's okay, I can share this. And type here the password, and here we have.
Can you please increase the font size of the web browser?
Yeah.
Okay.
Something like this?
Yeah, it's better now.
Okay, thank you very much. And yep, actually here, if you go to StackGres clusters, there's one called Simple, which is exactly the one we created and has 2 instances. Here you see the disk, they're healthy. And if I click here, I can see some information about this, the total CPU that is being used, the memory, the disk, and a few other details. Here, this is the primary, this is the replica. I can review the configuration, how this was created. I can see here that it used some default configuration for Postgres for connection pooling, for the instance profile. I can check here what the instance profile is using. I'm going to get into this back later. And right now, backups are not configured, but if they were configured, they will show up here. I'm going to show you later how they will pop up here, the backups. The most important part, by the way, about this web UI, the most important part, this is no question, is that it has a dark mode. So whatever you prefer, light or dark mode, you are well served. All right, so we're done with this simple demo. Let's actually delete this one because we're going to do a much more advanced and really cool demo. So let's delete the cluster. How do we delete it? Actually, we can use this command, or I can do a delete to the simple cluster, and this will have the same effect. And we can see now that the pods are going to be being deleted. I'm just going to wait a few seconds until the pods are finally terminated. And then I will just run this other command, which is, as you can see, the opposite of the one that I used for the installation. And that will also delete all StackGres. StackGres, the software itself, right? Okay. So let's delete this, and in a few seconds, StackGres will also be completely deleted. This way of installing and uninstalling StackGres, by the way, is just for demo purposes, not meant for production use. The one I'm going to show right after this is more meant for production use, and it's also all documented on the website. And it will not work anymore because I just deleted the cluster. But if you go to stackgres.io/doc, stackgres.io, you'll see here all the information about how to make a production installation via Helm. That was one of the questions, and we're going to go with it. So while this finishes deleting, any other question that was pending there on the list? If not, I'll move on to the next one because we're actually done here.
We have more questions. Do you want to keep going, or want to stop to reply and keep going?
Let's take a couple of questions, maybe.
Okay.
As you can see, there's a lot of stuff here pending. So just look at this.
Yeah, I agree. I think it's a good idea to reply one or two and keep going.
Okay.
The first one is possible to use a customized image of Postgres? Okay.
We have a very StackGres is an opinionated stack, which means that we have a strong opinion. We have been using Postgres for decades, myself 2 decades, and we have very senior Postgres engineers and DBAs. We believe that we have an idea of what we're doing. As such, we need to make all components very tightly integrated. Sorry for the long answer. This means no. This means that we have very tight control of the image we're providing. It's just vanilla Postgres, as I mentioned before. No fancy stuff there. It's compiled by the project, by StackGres, but it's no patching to the source code, vanilla Postgres from upstream. And because of all the integrated, it will be very, very hard to provide customized images. They will need to comply with a very strict protocol, and even then, might not be able to program all this automation together. So unfortunately not, but I guess it should be sufficient for most people because this is, again, vanilla Postgres. And then we're going to provide you the option to install any extensions that you want.
Got it. Fabiano is comment that he is worrying about the commits on the application. So he's worried about if the application commits something and the data isn't stored on the data files. Is worries about what happens if you lost the container and we lose the data. The failover will fix that. There's a lot of questions. I try to resume into a single one.
Yeah. Okay. Thanks for that. So this is not different from regular Postgres. What will happen if you have a cluster run by Patroni, for example, and one node fails? Well, first of all, if data has been committed, that means that it has been stored durably on disk. May not be on the tables files, but maybe on the wall files, which means it's recoverable from there. Because we're using persistent volumes and we're not using local or ephemeral volumes, if a node dies, the disk doesn't. So whenever a new node is being created, this disk will be reattached to the new node. So the information will still be there. And this is assuming it wasn't replicated to the other nodes, because if it's replicated to the other nodes, it will also be there. So is there a potential for data loss? Is there a potential for data loss if and only if you're using a synchronous Postgres replication, which, by the way, is the default. So on the default, yes, you may lose some transactions if, for example, you commit something to one node, and before this has been replicated to the other nodes, this node fails. And when it comes back up, this node has been elected the master. But this is, again, the same as with a non-Kubernetes environment. Exactly the same. There's no difference. You may also incur in the same, potentially, data loss. Typically, this is very small probability of data loss because Postgres replication is very fast, very efficient. It's under a few milliseconds, under a second for sure, most of the time, and that's what. Now you could use also quorum commit for the replication, and that's a more advanced mode. It's not exposed as of now. Few people use it, but it's possible, and that guarantees absolutely no data loss. But this is the same regardless whether you're on Kubernetes or outside Kubernetes. Actually, Kubernetes makes it better because, as you have seen before, a kill node comes back online very quickly. On a different environment, maybe you need to set up manually a replica or have more complicated automation for bringing it back.
Okay, but this is something that the Kubernetes and the StackGres do by itself. You don't need to do anything. If you lost the container that runs the database, they will self-heal and work, right?
Yep, as we saw just before.
Okay, I think there's a last question for this round. Avelina is asking if Postgres has a client that runs stacks on production.
Yes, yes. We have several stacks of StackGres in production, and I would say that it's working quite well. If anyone wants more reference, I can provide them later. Some of them are not public, so I cannot share all the information right now.
Okay, let's move on.
Okay, so yeah, anything else?
No.
Okay, let's move on to a more advanced demo. Now we're gonna make this a little bit more look like a production installation. So first of all, let's use namespaces. Kubernetes has this concept of a namespace. It's quite similar to Postgres schemas if you're not familiar with the matter. It's just a prefix to separate some objects. So let's create first some namespaces. This is pretty simple. We're going to create a namespace for Prometheus because we're going to enable monitoring, another one for StackGres for the software, and one demo where we're going to run some demo clusters. So let's just copy paste this. Pretty simple stuff. Create the namespaces. We're done. Now let's install Prometheus. Prometheus is a dependency. It's an optional dependency for StackGres. If you want monitoring, we support Prometheus, but you need to provide it. Fortunately, it's not so very complicated because with Helm, we can install Prometheus in one line command. Of course, if you want to customize this installation, you want to provide specific values for this Helm chart, you might also do that. But you can go to the Prometheus Helm chart documentation and find the parameters that you want to install. For us, it's transparent to us. So if you have Prometheus installed, we'll connect to it automatically, and we'll push a lot of information, as you're going to see, to Prometheus for monitoring. If you don't install it, you will not have monitoring. It's that simple. This is also very fast. We'll take a few seconds more, and we'll have Prometheus installed. Cool. It's installed, and I can just copy and paste this command. Yep. Looks like it's not finished yet, but I don't mind. It will be in a few seconds. Probably it's already not there, but it will be in a few seconds, as I say. All right, so we're good with Prometheus. Now let's install StackGres. So StackGres also supports Helm installation. Normally, I would just say something like this and the last line, and that will be enough for installing StackGres with Helm. But I'm going to override some specific values which are required, first of all, to enable Grafana. So if I just want Prometheus monitoring, there's nothing else that I need to do. But if I want also StackGres, as we will see now, from the web UI, has the capability to embed Grafana inside of this web console that I just shown you before. But for this, I need to provide some parameters. So I'm using Helm, the pretty much a standard way, but I'm going to override some values about Grafana, which is basically, please auto embed. I'm telling the domain name where Prometheus is installed. This is standard values. This is Prometheus default user, and this is Prometheus default password. There's nothing specific here. And also, I want to expose the web console through a load balancer. It's not the default on the Helm chart, so that's why I'm using this. So before running this command, let's just check that the Prometheus operator is finished. The installation should be. Oh my God, I did the wrong command. Sorry about that. I will do the job. Okay, this looks good. All the Prometheus infrastructure is ready. So let's go to install StackGres via Helm, which again just means running this command. Let's copy this, paste, run. Oh my God. I think this will be better. Excellent. This will take a few seconds also to install StackGres. Let's switch to another console in the meantime. Sorry, StackGres tutorial. And let's look at the next stages. So once we have StackGres installed, not yet, but it will be there in a few moments, we're going to create another cluster like we did before. But before going to the SG cluster, the CRD that represented the cluster, we're going to create other CRDs. StackGres exposes more CRDs, these high-level APIs, and allow you to do a lot of customization of the installation. They're all optional, but they allow you for this customization. So one of them is called the instance profile, SG instance profile. It's pretty simple. It's just the number of CPUs you want for the nodes and the memory you want for the nodes, for the pods. And you assign it a name that could also have optionally namespace. This is very simple stuff. This is, think of a t-shirt size. Say you want to standardize and you want all nodes, not only of this cluster, but also of all the clusters to be created following some standards. And you can create some t-shirt sizes, the small one, the medium one, the large one. And then instead of going and specifying for each cluster which instance size do you want, you specify the name. Just say size is small. It's like a foreign key. So from an SG cluster, I can do a foreign key to a given profile name, and then I am standardizing. So this is a best practice. This is already, okay, so StackGres is already installed. All looks good here. Yep, see, this is the ASCII art. And all is good here installed. So let's close this shell. We're good here. And let's run the, also let's check the box just to make sure. Same as we did before. Yep, all looks good. StackGres is installed. So let's start creating these CRDs. So the first one we said is the instance profile, right? So same stuff, kubectl apply -f, and the instance profile should be created very simple, nothing fancy here. Let's move on. Same stuff with the Postgres configuration. We might want to reuse Postgres configuration. StackGres allows you through this CRD, the Postgres config, to customize the configuration. We provide a lot of default values that follow our best practices, and they are very well tuned for any almost default installation. They are not as conservative as Postgres defaults. But still, you obviously have the option to override our defaults or tune all the parameters that we might not be tuning by default, and this is the parameters that you want to provide. So just create a simple YAML file, give it a name, optional namespace, specify the major version for which you're providing these parameters and the parameters that you want to tune. And now, once this is created, we can, for every cluster we create, we can reference this name, and this configuration will be applied. Just figure out how comfortable this is. We're touching a YAML file. Anyone can touch a YAML file. Of course, you may need to know which parameters and which values to put there, but you don't need to understand how to configure Postgres, how to restart it, or how to propagate this through all the replicas, or which values are allowed, or what the syntax is. We're hiding all those details for you and making it super simple except for setting up the values, obviously, right? But there's nothing we can do about that. But at least reference by a name and make it very simple. So let's also create this. Same stuff, apply f, and this Postgres config. And now the very same stuff with the connection pooling. We have another CRD, which is called SG pooling config. We give it a name, and we specify PG bouncer parameters. Same stuff. Let's also create it. All right. Okay, now let's create backups. So let's also talk about backups. StackGres is capable of managing backups automatically for you. It uses internally WAL-G, which is a system for taking backups and pushing them to cloud storage, which is the most reliable storage available, and automates all this, even the life cycle. You know that continuous archiving in Postgres requires to take snapshot of the disk called base backup, and then incrementals in between those. And how many base backups do you want to keep? As many as you want, but also StackGres handles this retention for you. So if you say, I want to keep 5 of them and I want them to be spread every day or every week, it will delete and create backups automatically for you. So basically, you don't need to do anything. It's like Amazon RDS or any equivalent system, fully managed, and you can create backups like this. Now, these backups will go to, in this case, we're in Amazon, they're going to go to an S3 bucket. And we need to provide the credentials for this S3 bucket. So first of all, we're going to need to create a standard Kubernetes YAML file, which is the secret. And it's going to look something like this. And here I need to put an access key to the S3 bucket and a secret key to the S3 bucket. Now, I don't have a bucket. So first of all, I need to go back briefly to this section, and I'm going to create a bucket. I have another script here, which is a little bit more complicated, but it basically creates a bucket. So I'm gonna run this command, and I'm gonna redirect the output here. This command is gonna create some the bucket, and it's gonna provide these credentials for me. It's gonna run it there. And okay, just not to stop sharing the screen, I'm gonna show this briefly. Please don't copy it. I will delete the bucket afterwards anyway, but otherwise it's gonna be public. So I don't want to stop sharing the screen. I'm just gonna copy the last command, which is a command that will create the secret that I require from the credentials from the command line. It's gonna be this one. Let's run it. And that's it. So I've got now the secret created. I can go back to where I was. So this is equivalent, as I said, to creating this YAML file, except that by running from command line, this has already been placed. So I have just created an S3 bucket in the Amazon cloud and created the secret. Now, I'm going to create a backup config. A backup config is yet another CRD that we expose that defines how to take backups automatically. And I also give this a name. So when I create a cluster, if I want this cluster to have backups, I will just say, hey, use backups following this config. And this config, what it contains? Well, it's a little bit more involved. That is, anyway, it's pretty high level. This is the base backup cron schedule. This one, of course, we're running a demo, so I want a base backup to be taken every 5 minutes, and I want a retention of 6 of those. So basically, I'll have 30 minutes of data stored. I want them to be sent to S3. They're using the same bucket, which I just created from the other script. And to access the credentials, please read them from the secret that I just created. This is the name of the secret that I just created with the previous command, which I typed quite fast because it contained the credentials there. Didn't want to stop sharing the screen. And you can access the key from this key and the secret from this other key. So let's create this. This is, again, another YAML. So just kubectl, apply, let's add this file, and this will create a backup copy. Cool. So let's recap. We have installed StackGres. We installed Prometheus and StackGres via the Helm operator, their Helm chart, sorry. And then we created an instance profile, which is a t-shirt size, customized Postgres config, customized PG bouncer config. I have created a bucket in S3 to store backups, and I created an automated config backup configuration. Let's show yet another new CRD. And this new CRD is called distributed logs. And this distributed logs is one of my favorite functionalities of StackGres, something that you will not find right now in any other Postgres distribution or installation. This is the functionality that allows you to send the logs from all the pods to a central location. The central location is, surprise, another Postgres instance. We're setting up another Postgres instance. We're taking all the logs from all the pods. All the pods contain a sidecar, which is FluentBit, which is an agent that is going to read the logs from Postgres, and they're going to send them to this central location. The central location has 2 pods. One is a software called FluentD that collects those logs, unwraps them, they come in CS value, unwraps them, and inject them into Postgres, which is another container that is stored inside these distributed logs. And all the logs come to a Postgres table. And then you can query them with SQL. So isn't that cool that all the logs are coming from all the pods to a central location, and then you can do SQL queries in those logs? At least I love it. And then we also show them from the web console. I'm going to show that to you too. So in the very same spirit, I'm going to create a distributed log server, and I'm going to give it a name. And now I can choose for any cluster that I create to use a given distributed logs. I can use the same distributed logs for many clusters, or just one distributed log server for each cluster. That's my choice. I'm going to give it a few more room here. And well, it's actually an example anyway, and I'm going to give it a name. Let's create it. Same stuff. So now I should, this is all being created on the demo namespace. I should see the distributed log servers being created. And now we're ready to create the cluster, which is going to be very likely here. And the cluster. Well, I'm going to show you the cluster YAML first. So this is a little bit more advanced YAML. It's still only not very long, 32 lines, right? 32 lines, and it's a little bit more advanced. So let me go over the differences. with a very simple example we did before. So first of all, we're explicitly calling a Postgres version that we want. It's going to be 12.3. I want 3 instances instead of 2. Then I'm going to explicitly specify the t-shirt size, the size small that I want, the instance profile that I created before. For the pods, I want them to be 10 gigabytes, and I'm explicitly specifying the storage class that I want here. So if you're on-prem and you're creating your own storage class, you can specify the storage class that you want here. Then I'm going to use the foreign keys for the custom Postgres configuration, for the connection pooling configuration, and for the automated backup configuration that I want to use that I just created before. And as well, I want the logs to be distributed and sent to this distributed log server that I also created before. Another cool functionality that comes with StackGres is that I can initialize my database not to be empty. And I can also type here scripts that I want to run upon creation of the database. For example, this one will create a database called pgbench, which we might use for running a benchmark. And also, so here's a literal. So here, because of using this pipe in YAML, I use a literal script here. But I can also, if I want to run something that has some protected information, I can store it on a secret and say, read the script from a secret. And I provide the name of the secret and the key within that secret where to read this more confidential, or at least I can protect it differently from being a secret. And so here I have another script that will create a user and will reference this secret. So I need to go now and create the secret first. And also I'm including this Prometheus auto-bind true, which means it's gonna create a service monitor, which is the component that StackGres requires for linking with Prometheus automatically. So I'll have metrics exported to Prometheus. And finally, this is a non-production option. I don't need it right now, but I just wanted to show it. By default, StackGres will not create more than 1 pod in same physical node, physical, virtual, whatever. But this is not a good practice for production use. If you want to override this, you will use this. So let's go first and create the secret. The secret is very simple stuff. It's a secret. I'm going to show you the secret. It's basically, this is the SQL code. So I'm going to use okay, this is a password, doesn't matter. So I'll just run this. This will create the secret. And now I'll do, this is the secret, obviously, that I'm referring to here for this script. Right? This is a secret I just created. Now I can play this. This is a YAML file, so apply f. And hopefully this will create a cluster. In the demo environment, demo namespace, get pods. Let's watch on this. Cool. Yeah, looks like starting to create some clusters here. While this is being created, let's go back to the web console, because as I said before, all these things we can see from the web console, right? So let's recap the web console. And if you remember, we typed this command for accessing the load balancer. This is a new load balancer. Let's connect to this new load balancer, the HTTPS. Yes, it's a self-signed certificate.
Please increase the font size when you can.
Yeah.
Thank you.
I mean, let's retrieve the password. Yep, it's password. Okay, cool. So here we can see the cluster is being created, but sorry, not yet, because we're on the default namespace. We're creating this on the demo namespace. So let's switch to the demo namespace. And here, okay, yeah, we can see the cluster is being created here. But if we go to the instance profiles, for example, we can see the instance profile that we created here. As I told you before, whatever I do on the CRDs on YAML will be reflected on the web UI and vice versa. So similarly, we should have this PGConf one here, which is a Postgres configuration which we created before. We can see here that this is the parameters that I explicitly specified. And this is, by the way, the default parameters that are automatically tuned for me and come with the default tuning that we do for Postgres. Here, by the way, you can get some information linking to this website that I also mentioned. You can find all documentation for given parameters. So this comes quite handy. And similar to connection pooling, I can see here the configuration for the custom configuration I did for configuration pooling, for managed backups, and so forth. I can also see the distributed log server that I created. And very soon I'll have the cluster ready. And here we go. So pretty much everything looks good here. I have the 3 pods, and this one has been elected the master. They all have 6 containers. Everything looks healthy. This is the disk space being used. Looks good to me. If I click on the...
We have a question here, Álvaro. I think it's related to the setup. The initial data can run a script from a config map.
Yes.
I think it's precisely what they did, right?
No. So there's 3 ways of providing an initial configuration script. Inline, I use this one. From a secret, I also use this one, or from a config map. So yes, those are the 3 options. In the future, we'll also want to provide the option of fetching a script from a Git repository or from a public URL and also run it.
Okay. Avelino is asking if StackGres recommends some magical way, like the Velero to run the backups. I'm not sure what is Velero. I think it's a backup tool. I'm not sure.
Yeah. So as I said before, StackGres is very opinionated. We made a choice about which solutions to use because it's not easy to swap one solution by another one, right? So we're choosing open source components, which we believe are the best in each category, and we are bundling those. So no, there's no option. I mean, you can use other external tools for making backups, absolutely, but they will not be integrated here or work the same way they work here. But that's okay. But if you believe that, for example, we're using for backups, we're using WallG. If for any reason you believe that WallG is not the best tool and should be another one, raise an issue. The issues are public. Just go to GitLab, where we host their code repository, create an issue, and explain why, and we'll definitely look into that. But we believe for now we've made a good choice in general.
Okay. I have an old question that I forgot here. Avelino is asking how StackGres handles the horizontal pod outscaler. I'm not sure if StackGres uses, but if it handles.
Yeah, no. So it's not using the horizontal pod outscaler because scaling a database is not such a obvious thing to do, right? It's a potentially disruptive operation. We're dealing with state here. But if you want to scale this, you can just, for example, say this cluster, I can go and edit the cluster. Now let's do it from command line and say, I want 4 instances instead of 3. Right? And then update the cluster. I'm not going to do it because actually right now I have only 3 nodes, even though I use this pod anti-infinity. But you can just do it, and it will create a new instance. This is manual. This is not automatic. But you can also set up some metrics and edit the CRD if you want to scale the number of instances.
Okay, I'm leaving.
All right. So so here, anyway, we can see the configuration. This is a whole config. This is like the view of the YAML file that we used. Here we can see this. This is the instance profile that we use. This is the configuration, for example, right? And here I even have these details. This one is hidden, but this one is not because this is the script that I used because this was a secret and so forth. Now, what about? Well, let's actually do something else with the cluster, and we'll come back here. So now I said that the cluster is created. We have seen this. Let's actually do a PGConf, for example. Let's connect to this called cluster, and this is running on the demo namespace. So let's connect here and let's run a run query. For example, let's actually say this will fail, right? Okay. I just want to create an error so we can see later in the logs. And let's also generate some traffic. So let's run a PG bench against this cluster. So what we're going to do here, we have these 3 pods with the cluster. And let's create another pod with the standard Postgres image. This is not StackGres stuff. So this command will create a Postgres container, Postgres pod, and it's called PGBench, and it contains a Postgres server, but I'm not going to use it. And more importantly for me, it contains PGConf, and also contains PGBench. And so I'm gonna connect here. Interestingly enough, look at this part of the command. When I am outside of so before connecting via PGConf, what I'm doing here is just doing a kubectl exec. This is run a command inside the container. This is not the way your applications are going to be connecting to StackGres. Your applications are going to connect to StackGres normally via the DNS. This is the DNS that is created automatically by the service, that is created automatically by StackGres, and it's stable. This always points to the primary and it's composed of the name of the cluster dash primary dot namespace, right? So, but from any pod in this Kubernetes cluster, I should be able to connect to Postgres with this. So here I'm just going to run a pgbench. I'm using not SSL, and there's a reason for this because I'm going to show you the metrics that are captured by Envoy. Envoy right now doesn't capture metrics over SSL. This will come in a later version. So because specifically I want to show you some metrics, and otherwise I'm going to run on this container, which is external to the Postgres cluster, a pgbench. First, I will run the initialization of the tables. It asks for the password, which I created on this secret, if you remember, to run more or less fast. And then I'm just going to run a quick test over to a couple of minutes. And while this runs, I'm going to show you some more stuff about the web UI. I know we're 6 minutes over time, but I think we can continue for a little bit. If that's not a problem for me. I hope it's not for anyone else.
No problem. Take our time, man.
All right. Okay. So this is about to finish. A couple of seconds there. So if you're not familiar with pgbench, this is just initialization of the data that is going to be inside of the database for running the benchmark later on. Okay. So again, this is the pgbench stuff, and now let's run the benchmark itself. We're not interested here in performance. No. We're just interested in, and this is very small machines. Sorry. Let's go back to the web UI because I want to show you the logs. So as I mentioned before, because we're using this log server, these distributed logs, right? All the logs from all these 3 pods that we have here in this cluster, right? All these 3 pods, they're all sending the logs to this central location. And they're sending both the Patroni logs and the Postgres logs. And I can query them either with SQL, but I can also query them from the web UI. So let me show you that because I believe it's pretty cool. So here you have all the logs that are captured from all the pods, both from Patroni and Postgres. I can do full text search here, and I can filter. For example, let me filter by Postgres because I prefer now to see the Postgres logs. And here you can see actually this error that I tried before by doing a select instead of select. You know, there was a mistake there. So actually, because this font is a bit big, you cannot see the whole thing. That you can see here that this is the Postgres log that was created. And I have here a lot of information where it was created, the user, the database, Postgres ID, where it was connection, and the session ID. Well, you know, all the information that comes with any Postgres logs, it's stored here. And for me to query in a graphical way is super easy. So here I have I can filter by error level, by type, it's Postgres Patroni. I see the role of the system. So here I can see all the information that comes from both Postgres and Patroni, and it's happening to the Postgres logs. So this is one of my favorite features of StackGres. This centralized log, there's nothing like this in the Postgres world. List so easy to use with just this YAML file, so automatic. Let's look at the backups, because we also created some automatic configuration, and this should be creating a backup every 5 minutes. And yeah, here we have 2 backups already created, right? Okay, this is the storage that you're using. This is the name of the backups. And I can click on any one of those, and I'll get all the information about this backup, when it was created, what was the start LSN, the end LSN, a UID that I may use later on for restoration in another cluster, where it was created, what is the timeline, system identifier at the time, where is this stored, and so forth. So here you have a lot of information I can parse and I can use for every backup that is created. And as you can see, I almost did nothing, just create a few YAML files. And all this is created right now for me. And every 5 minutes, I'll get here a new backup. I can delete them, but otherwise they will be deleted automatically, because this is I specified on the backup configuration, which, by the way, we can see here that there's a retention of 6. At most, I'll get 6 backups there. Sorry, the backups. And last but not least, let's look in the monitoring. I'm going to make the resolution a bit less here, even though the font size will be a bit less, so you can see more real estate on the screen. And here, because I used all this Grafana integration, I have a lot of dashboards that have been automatically integrated for me. So for example, here I'm visualizing the cluster 0, and I can see, for example, all these metrics. This is the metrics about the PG bench that I'm doing right now. These, by the way, these metrics, these dashboards come from Envoy. So Envoy is using this Postgres extension that I mentioned you before, and it's exporting all these metrics to Prometheus. That you can read more detail about this functionality in this blog post. And by the way, I have to say that most of this work has been done by Fabrizio, the same Fabrizio who's organizing this. Thank you very much. This is really awesome functionality. We can even dive deeper, and we can see here the statements and see how many update statements, select statements, delete, none, insert statements have been here. So I can see that this benchmark is doing like approximately 45 inserts per second, but is doing over 134 updates per second. Isn't this cool? And this is running at the proxy layer. It's not running on Postgres or requires any other installation in Postgres, and it's all automatically created for you. I can see how many messages are being processed from front-end and back-end from the Postgres protocol. I can see the number of sessions, the user sessions here. We're running at a rate of a few sessions, right? This is a small number of sessions. I can see if there's any errors, which I guess there's no errors. Oh, there's some errors here. Interesting. And of course, you know, like general database stuff, the average memory usage, CPU. As you can see, there's a lot of panels that we are providing here that provide you very useful information about managing Postgres, the cache hit rate, for example, right? Or it starts about the background writer. And how complicated would it be to do all this by yourself on any environment? And here was just a matter of a few YAML files. So at this point, I may open for more questions. There's a bit more, just a couple things more I may demo if we have still some time, but maybe there's some questions.
No, they are so quiet right now. I think they got scared. They start, oh, this doesn't work, and then we start showing all these wonders that StackGres do. They, okay, let's be quiet and listen.
Excellent, excellent. All right, so then let me go back to the cluster itself, and let's then finalize the demo. This is almost everything that I have, but now let's do something. Let's delete this cluster. Pretty simple stuff. I'll just delete the YAML file that created this cluster, and I'll do this because I want, right? So now I'll see that this, but on the demo namespace, yes, demo. Yeah, they're being deleted. The cool thing is that the backups remain, obviously. There are backups, or they should. Here I have some backups. Actually, I can see that these first ones were before I ran the PG bench data initialization. Here's the one with the data. So actually, what I'm going to do is now I'm going to create another cluster. Right now, there's no clusters, right? I'm going to create a new cluster, but I'm going to create it by restoring a backup. So I'm going to take this backup, and I'm going to look for this UID. I'm just going to copy this, right? And let me make the font size a little bit bigger. Sorry about that. So anyway, here's a backup. Let me refresh this. Here's a backup, and I just took the UID from this backup. And what I'm going to do now is create a new cluster and restore this cluster from this UID. I could do this graphically, but you know, there's a few parameters that if you remember, it will be exactly the same. Trust me. But I'm just gonna go. This is finished already, right? Well, it doesn't matter. Yes, it's finished. So what I'm going to do is I'm going to copy this SE restore here, and I'm going to edit this file. It's pretty much the same as the cluster we created before, except for this section, initial data, right? So I'm going to say initial data, do a restore from backup. And here, I'm going to specify this UID that I just found on the web UI. I could also do it from the command line. This, again, the YAML file is pretty much the same. Obviously, I'm not specifying initial script. It doesn't make any sense here. It's going to restore it from there. Should have all, actually, we'll see, because it should have this big bench information. And otherwise, other than this, it's just called restored, and that should be it. So let's see. Let's see if this works. I'll apply this file. And if all goes well, in a few seconds, this restored cluster will be restored from this backup. It's initializing already. I can go back to the web UI. Yes, sorry. I think either the font is too big. Yeah, I don't see here. Okay, it's big there. Restored. Here it is, and yeah, it's been created. Let's wait a little bit until this finally is created. There's one node almost there, 5 out of 6 containers. And one is going to be created. Well, the configuration, obviously, it's I can see here that it's being restored from this backup. I can see the backup here, the backup information, can come back to when this backup was taken, how long did it take, and so forth. And within a few seconds, obviously, I'll have this cluster created again from this backup. So actually, the primary is already created. As we can see here from the disk space, it really looks like it restored something from the backup. To test this, let's, even though it's on creation, let's run the pgbench again. So I'm just gonna run the pgbench now, because this is called restored. The DNS name of the restored cluster is gonna be, it's always sg cluster name - primary .namespace. So I think I can already run a pgbench here. Performance may be weird because we're just creating the cluster, fetching the data from the replica, and so forth. But it doesn't matter. What I want to see is that it works, and it doesn't show, but it's already working.
Overall, about the backup, it's possible to do some point-in-time recovery, select some time that I want to restore.
Okay, let me show you something. So, so if I go to the public issues of StackGres, StackGres is all developed in the public. It's all
Please
open
enlarge
source.
the screen.
Oh yes, sorry about that. So sorry. It's open source, but it's also developed in the public. All the issues are public. You can go here, and so PITR is not developed yet, but it's planned. So actually, I can go to the issues. I can look for it, PITR, and very likely, oh, here's the issue. Add support for PITR, and it's planned for StackGres 1.0, right? So if you like this, go here, give your opinion. You can drop comments on the issues. We'll look at them. And if you want to suggest some other feature, also go and look for it. By the way, being on this webinar, I would strongly suggest you all who are interested in StackGres, apart from going to both, I really appreciate if you go both to GitLab and GitHub, where we have a mirror of the project, and star it. We love stars, and they will help other people realize if this is a good project, if it's a nice project for you to realize that it's something that is worth checking. But also, if you go to the StackGres.io website, there's also here the Slack community and Discord community. I would strongly recommend you to join Slack and/or Discord community. All of our StackGres team is there. If you have any questions, you can ask there. You can interact with all the creators of StackGres and create a real community around it. So please star us, go to the communities, join the communities, and obviously enjoy this is open source. So just to finalize this and then go back to the last questions. Yep, the cluster was here. The benchmark run, which means that the cluster was perfectly restored. And actually, I can do also PSQL here and list the database. Yeah, this is not cluster, but rather restored. And I can see that the pgbench database is there, which means it was restored. And well, I can also list the size. Yeah, pgbench here, 160 megabytes. And so I was also able to restore from this backup the Postgres cluster. And that's pretty much the demo. The rest that I have is just some cleanup commands. There's a few commands there for cleanup. I'm not going to get now into these details, but this is also on the old source code that is published, which is here. I showed the URL before, but here's this StackGres tutorial. And I think I open for the, let's go here to the web UI. I'm open for the last questions. We might see, obviously, the monitoring here. Just to finalize on this. Also, the monitoring is working. This is this pgbench that I just showed before. Logs should also be working here. And at some point, there might be some new backups here. Maybe it's less than 5 minutes, but they will start appearing here. So, yep. Surprisingly, everything worked in the demo. Lucky me.
I have a question, and it's not up in there, but there's so many great things on StackGres, and I'm wondering if it's really free and open source. Because
it
sounds too good to be true.
Well, it is. It is absolutely open source. And as I said, it's not only open source. We're developing it in the open. The issues are open. You may go and comment on them. You may join Slack. We will respond to you in Slack also for free. Now, if the question is then how you make money out of this, because this should help cost a lot of money, yes, it does. But we commercialize a version which is called Open Source StackGres Enterprise, which is the same version as the open source, but comes with a commercial license. Comes with 24/7 support from our team, and also comes with a maintenance lifecycle of 5 years, whereas StackGres open source is all maintenance lifecycle of 2 years, which means that after 2 years, StackGres open source will not be maintained, but StackGres Enterprise will be for 5 years. So if you want to run this in production, you're more than welcome to run open source StackGres and be happy with it. Yes, we'll appreciate some tweet or some blog post or something to mention how cool is this if you think it is. And obviously this starts on GitLab, GitHub, and Slack, joining the Slack community. But if you want some 24/7 support, that will come with StackGres Enterprise and commercial license. We're happy to obviously talk about that.
Awesome. Waiting for the question, but Avelino had a comment that saying that he is a maintainer of the PureRes project, which is an open source project that provides a RESTful API for database, and it's written in Go. And is wondering if that can integrate with StackGres. I think we need to reach to you, I guess, in Twitter or open an issue on StackGres.
Yes. So another feature we're planning for the next versions is the ability to deploy other applications that will run on top of Postgres and integrate them with StackGres, even with this web console. This will require some effort. It's far from trivial, but we definitely want to do that. So reach us out.
Okay, so no more questions, I guess. Waiting for the guys wake up. Wow, while they think about it, I want to thank you. It was an awesome talk. I learned a lot. I always love to see you presenting something. I always remember that I have something to learn. And I don't know, I have no more questions. Do you have something else to show us today?
That was it from my perspective. So yeah, I'm good to go. If there's no more questions, or I can take more questions, no problem.
Yeah, Fabiano is asking again about the production environment, but he said this, well, I'm here late. So you already said that we have customers running StackGres on production.
Yes.
And I think that they can reach you to get no more details about it, I guess.
Yep. Yeah, absolutely. If you want, find me on the Slack channel, on the StackGres Slack, and send me a direct direct message there, and we can take it from there if you want.
Awesome.
Thanks a lot, man. Again.
My pleasure.
Yeah.
That was awesome. There is no better word for that.
So now we switch to Portuguese to finish the presentation, okay?
Sure.
Okay.
Então, pessoal, muito obrigado pelas perguntas. Aqui a gente está encerrando a PGConf 2020 e, como a gente falou no início, acabou se tornando um evento bem curto e online por conta da pandemia, né? Nós esperamos que para o ano que vem, para 2021, esse problema já tenha sido sanado e a gente consiga fazer um evento novamente como todo mundo já conhece, com toda a diversão, com palestras, com tutoriais, com lightning talks e com a cerveja do evento, claro, né? Muito importante.
A galera vai só pelo happy hour, né? Agora vai sair usando StackGres e não quer saber de mais nada, né? Agora o operador faz tudo, a gente só bebe.
E não deixe de assinar o canal, marcar o sininho ali e sugerir conteúdos, lives da comunidade, que a gente está sempre disponível para para entregar conteúdo e para compartilhar. O Teles está escondido aqui no fundo. Eu não sei se ele não quer dar uma última palavra. Afinal de contas, sem ele a gente não teria feito nada disso, a gente não teria rebatizado o evento, a comunidade Postgres do Brasil poderia já ter até sucumbido, né? Mas é verdade. Em termos de evento...
Só para encerrar, tentando não me alongar, que é algo difícil para mim, existe gente já querendo ajudar a organizar o próximo. Eu acho que a gente ainda vai fazer mais um aqui pelo estado de São Paulo. A gente gostaria de fazer algo muito parecido com o que a comunidade de Python faz. Que o próximo evento seja organizado por... Se você quer organizar uma conferência de Postgres nacional, você participa da próxima e depois você organiza a sua. E eu queria muito já estar marcando um lugar para fazer, uma data, mas como as coisas no Brasil ainda estão bastante incertas, os números ainda não caíram, é muito difícil dizer, olha, tal data vai estar tudo tranquilo para a gente fazer um evento de grande porte. Quer dizer, de grande porte não, de médio porte, mas de poder reunir todo mundo junto no mesmo espaço. Então a gente vai ter que esperar um pouco mais para poder marcar o próximo evento, mas eu espero que em 2021 estejamos todos mundo juntos para poder celebrar o Postgres junto e trocar figurinha e beber e tudo mais. Foi um grande prazer e fica ligado, se inscrever no canal, no Instagram, no Twitter, no Facebook, etc. Ou inclusive entrar no grupo aqui do Telegram, também tem o grupo do PGConf, onde a gente está sempre conversando por lá. Tá bom, gente? Foi um grande prazer e, assim, fechamos com chave de ouro, né? Essa palestra do Álvaro foi, show de bola, gente. Parabéns.
Thanks a lot, Álvaro. Pretty awesome, your presentation. I think a lot of people watching your presentation see that we have a light at the end of the tunnel to make things better to using Postgres on the cloud, and of course using on Kubernetes. Thanks a lot again. You always be very welcome to be here with us, and I hope next year we can meet in person in São Paulo, have some beers, have some fun, and talk a lot about PostgreSQL. Thanks a lot, man.
You are missing the barbecue, man. They just come here for the barbecue.
Yeah.
You can lie whatever you want. They come here for the drinks and the barbecue.
Yeah.
And a bit of Postgres too.
Sometimes the Postgres.
No,
Okay.
I really appreciate your invitation, and I really hope I'll be able to make it in person next year.
Ok, thank you, man. Obrigado, Sebastian. Obrigado, Fábio. Então, nos encontramos próximo ano. See you next year, man. Thank you.
Bye-bye.
Bye.
Bye.